This is the video lesson for Algebra 2, Section 7.2, Properties of Exponential Functions. So we started with our original exponential function that we learned in the last section, a times b to the x. The parent function is just the b to the x. The a, if it's an absolute value, is greater than 1, it stretches. If it's in between 0 and 1, it shrinks or compresses. And then now we're bringing in, if a is negative, it's going to reflect it over the x-axis, and you'll see that. And then if there's whatever number you subtract from x, that's how much it moves horizontally. And whatever number you add to the end of it, it goes vertically. So here's all the transformations combined there. Okay, so for this first problem, it's asking how does each graph of the function compare to the graph of the parent function? You can just look and see, actually, I don't know why I took that down here. You can see here the parent function, right? This 0.5 here is going to, this is between 0 and 1, the absolute value. It's going to compress or shrink by 1/2, 0.5. And then the 2 is, and that's it. It's the only change there. This one, the negative sign is going to reflect over the x-axis. The 1/3 is your a. This is going to be a shrink or a compression, and then that's the only change. This one, the only change is this 2 here, and that's going to be, it's greater than 1, so that's going to be a stretch. Okay, and I think on the homework, I ask you to graph it, and then with the graphing, you just use Desmos. So you're going to graph the parent function and the actual one, and then you can show it, you know, like that. Because I didn't do the a, I think I included the a in the parent function, which is fine. You can do that or do both. But just show them both, the parent function and the actual function in Desmos, and then you can actually show the changes. So if you guys could press pause and do these ones on your own, then check back for the solution when you're done. Okay, here this negative reflects over the x-axis. This 0.5 compresses it by 1/2. This -4 means it moves, right 4. Stretch by 20, up 10. Pretty similar to all the other translations. Okay, here are 2 more for you to do. So press pause and try these on your own. Okay, this is left 2, stretch 5, up 5. Okay, now moving on. Moving on. So you may have seen a button on your calculator with this weird E, and you kind of always wondered, what is that thing? What an E is, it's called the natural base. There is some very technical and mathematical cool things that led to the discovery of this natural base E that's super cool in calculus that I'm not going to get into now since this is not calculus. But trust me, it's a very cool number. It's just like pi. It's an irrational number that just goes on, no repeating. But it's pretty cool. Anyway, it's a number, but we call it E, and it's called the natural base. And so the first thing we're going to do is just practice using this with a calculator. So you're going to just take your Desmos and hold on, let me bring it in and I'll explain how to do it. Okay, so I just made a quick video, but you can't hear the audio, but I'm just going to kind of walk you through it. So you can see down here, there's this letter ABC. You click that and you get the whole alphabet. If you click this E here, you can see that this is what your E is. It's this irrational number here. And if you go back to the numbers to do the exponent, you can then hit this button here, a to the b, that gives you the exponent, and then you can just hit your 3. I think I did 3. I didn't remember what it was, but I think I guessed right. 3, yeah, and then here it is. Let's just push pause on this video. I think I can. No, I can't. Anyway, you can do other things. I think on the homework it says to do e to the e. Just go back and forth between this one and this lettering here. And then this is what happens if you press 5. And so that's how you do it with Desmos. You can do it with other calculators too, but you guys have access to Desmos. But now I don't remember what e to the 3 was. Okay. And in the homework it says to go to 4 decimal places. So when you get the calculator, this comes out to be 20.06. Oh, sorry. 20.085 5. And the next number is a 3, so that keeps it at 5. So that's how you round to 4 decimal spots. And you kind of do squiggly lines because it doesn't equal exactly that. It's just about that. Okay, that's how you're going to be doing those. And let me see if I can delete this. Okay, here we go. Now, moving on, we're going to be using this as with money when we're talking about money. So in the last section, we did like you have an annual interest rate, but in real life, you don't get an annual interest rate. There is an annual interest rate, but the way that we were solving it was just once a year you get interest. But in real life, this is where E is mainly used. It's continuously compounded. So you're just always gaining interest, earning interest on your money. And the way that this works and the way that E was kind of discovered, this is the formula for continuously compounded interest. So I like to remember it as APERT. A lot of math teachers don't like to teach it that way, but I like it because it helps me remember. And this is your exponent on the E, where P is the principal, which is the starting amount of money. R is your interest rate, the percent as a decimal, and then T is the time in years, and it's with an annual interest rate. So let's see how this is used. Suppose you won a contest at the start of 5th grade that deposited $30,000, that's my P, into an account that pays 5%. So your R is 0.05. Annual interest compounded continuously. That's going to tell you this is APERT. How much will you have in the account when you enter school 4 years later? T is 4. Express your answer to the nearest dollar. So then you just plug these numbers in. 3,000 E to the 0.05 times 4. Okay, so when you put this in Desmos, you're going to do, right, the 3,000. Then you're going to go to the alphabet section of Desmos, click your E. Then you're going to go to the button that looks like this, A to the B, to get you up in the exponent. If you don't put parentheses around this, then if you did, E to the 0.05 and you hit times, it's not going to stay up there. It's going to come down here. So what you need to do is when you hit that A to the B button and you're at your exponent, you're going to put the parentheses and then do the 0.05 times 4 and close your parentheses. And that's how you get that in Desmos there. And then it'll just give you the answer. And then we need to express the answer into the nearest dollar. So this 2 does not change that to a 5. So it's just $3,664. Okay. See how that is used? Very exciting stuff. Last one for you to try on your own. I'll just write your APERT. And then this actually uses the problem before. So this is 4 years after high school. The one before was 4 years. You were in 8th grade, I guess. So it's 4 years of high school. So this is 4 plus 4. So this is going to be, your T is going to be 8. All right, sorry, I'm just solving this for you. Remember the P here was 3,000 and the R was 0.05. So just practice this on using Desmos and then check back for the solution. Okay, and hopefully you just plugged in your 8 here and then you got 4475. All right, that's it. Enjoy.